Computer Science A free response practice. This free response is done at the end of Unit 4, which covers iteration. First, we're going to look, or you looked at, a question from the 2007 exam, and it was only question 1 and part A only. Here you were told that a positive integer is called a self-divisor if every decimal digit of the number is a divisor of the number. That is, the number is evenly divisible by each and every one of its digits. For example, the number 128 is a self-divisor because it is evenly divisible by 1, 2, and 8. However, 26 is not a self-divisor because it is not evenly divisible by the digit 6. Note that 0 is not considered to be a divisor of any number. So any number containing a 0 digit is not a self-divisor. There are infinitely many self-divisors. You are provided with public class self-divisor. And the documentation tells you that parameters, the number is called number, and it's the number to be tested. So you're going to be passed a number to test. The precondition, the assumption is this number will be greater than 0, so you don't have to worry about that. You're going to return true if every decimal digit of the number is a divisor of the number, and false otherwise. Okay. So you're going to write the method is self-divisor, which takes a positive integer as its parameter. This method returns true if the number is a self-divisor, otherwise it returns false. So, when you go to complete it, you're going to write your code, and this is how it's going to be scored. Now here's the thing, is you don't get the scoring rubric before you actually write it. You're going to write your code, send it off, and they're going to come up with a scoring guideline. This particular guideline, though, I wanted to go over these scoring guidelines because notice that you get 2 points to loop over the digits. 1 point is if you access the digit, or each digit, in context of the loop. You get a half a point for attempting it, and a half point if it's correct. So if you have some little minor error and your program wouldn't run as it's written, you can still get a half a point. And if you process all the digits, if you attempt to process all the digits, you'll get a half a point. If you actually do process them all in your code, you would get the other half. The other 2 points is when you classify the number. Return false if you find a digit of 0 digit. You get a half a point if you test the divisibility of the number. You get half a point to return false if you find a non-divisor digit, and true for a self-divisor digit. Now notice that if you return a value instead of true and false, then you lose these points. Let's look at the solution. There are 2 different solutions. This first one uses just primitives. So you get the number n, and then you let n equal that number. Set n equal to that number. While n is greater than 0, you're going to pull off each digit. So first you're going to pull off the ones digit, which means you're going to mod n by 10. So you get that ones digit. Then you check if that digit is a 0, or if the digit, or if the number, okay, remember you want to use n because number is always the number. Number mod digit does not equal 0. If it equals 0, it's divisible. If it doesn't equal 0, it's not divisible. So if the digit is 0, or if number is not divisible by that digit, you can immediately return false and you don't need to check anything else. Otherwise, it passes that digit, you come down here, and instead of modding by 10, you divide by 10. That will remove the ones digit. So now the tens digit is now in the ones location. So when you loop back to the top, while n is greater than 0, you'll get that tens digit off. Okay? Bottom line, if you loop all the way through this and you check every single digit, if none of them return false, you get outside that loop, you're going to return true. Down here is an alternate solution where if you brought the number in and you changed it to a string, okay, so you've got str as a string, then you're going to pull each character, which is a digit, you're going to go through it one at a time, and the digit will be equal to the, you need to integer.parseInt from the string I plus 1, so you're pulling it off. This is a little more complicated, but some of you might see string manipulation as being easier. That's fine, and it works. Again, notice that your check here is the digit 0, or is number not divisible by the digit, then you return false. Otherwise, you're going to keep looping, and if you get all the way through the loop, never returning false, you will return true. Okay? From 2014, 1A. Again, you're only going to be doing problem 1A part only. This question involves reasoning about strings made up of uppercase letters. You were asked to implement two related methods that appear in the same class, not shown. The first method takes a single string parameter and returns a scrambled version of that string. The second method takes a list of strings and modifies the list by scrambling each entry in the list. Any entry that cannot be scrambled is removed from the list. For this exercise, we're only looking at the A part. So you're asked to write the method Scramble Word. The scrambling process begins at the first letter of the word and continues from left to right. If two consecutive letters consist of an A followed by a letter that is not an A, then the two letters are swapped in the resulting string. Once the letters in two adjacent positions have been swapped, neither of those two positions can be involved in a further swap. So notice the word tan. T stays by itself, the AN and swap. Abracadabra, the AB swap. Then we move up and we've got the R, then the AC swap, then the AD swap, then the AB swap, R, A. We can't swap anything because this last A is not followed by any non-A letter. So here, in each one of the cases when you've got the AP exam free response questions, they will not only explain the process, but they're going to give you examples. Look at the examples. It can answer a lot of your questions. Remember that you cannot ask any questions during the AP exam. So you have to be able to read directions, look at examples, and understand what is being asked of you. Now, if we want to scramble the word, notice on the AP exam, they're going to give you this information, this standard form of documentation. The parameter that you're going to receive is word, and it is the word to be scrambled. You're going to return the scrambled word, possibly equal to word. And the precondition is that word is either an empty string or contains only uppercase letters. So you don't have to worry about any lowercase. Postcondition, the string returned was created from word as follows. The word was scrambled beginning at the left, right, etc. Exactly what we just talked about. So here's the code. Current, okay, notice you get word in. Current is 0. String result is an empty string. While current is less than word.length minus 1. Okay, because notice if you're past the empty string, boom, you're going to return the empty string. Okay. Now, as long as it's not the empty string, that means current is more than 1. If word.substring, the current location, and the next one equals A, sorry, just the current one, you're looking for an A, and not current plus 1, current plus 2 equals A. So let's see if I can use a little pen here. This first part is asking, do I have an A? And is the next letter not an A? There's where the not comes from. So current up to but not including current plus 1, so you're looking at a single character. Is that an A? And is current plus 1 up to but not including current plus 2 not equal to A? Notice you do the not, because this from here to here is going to return true or false, and then the not is going to negate it. If you have an A and a non-A, result, okay, what you're going to do is you're going to take result plus equals word.substring current, so you're going to get that letter that came after the A, then you're going to add an A, and then current, you're going to increment it by 2 because these two can no longer be swapped. So you're going to bump it up. Otherwise, the result is just going to get the current letter, and you're only going to increment by 1. If current is less than word.length, result plus equals word.substring current. So that means you're going to just tack on the end of it, and you're going to return result. Okay? So here you access all the letters in Word left to right. That's what you're doing in your while. Okay? So notice you start with current is 0, and you're going to go all the way up, and current keeps getting incremented, either by 2 or by 1. Identifies at least one letter pair consisting of A followed by non-A. That's this right here. Reverses identified pair in constructing results string. Okay? That's what this does. Constructs correct result string. Point lost if any letter swapped more than once. So if you're swapping more than once, if you don't move past the letter swap, that could be a problem. And then returns the constructed string. Boom, right there. Does it have to look exactly like this? No, but it has to have these basic pieces. From the 2019 test, we've got an AP calendar. The class contains methods used to calculate information about a calendar, and you were asked to write 2 methods of the class. Okay? Notice that some of them will tell you that the implementation is not shown. That means this is an abstraction. You don't need to know the details. You just have to know, if you want to know if something's a leap year or not, you pass it the year, and it's going to return true if it is, false if it's not. You don't have to worry yourself about, oh, how do I calculate a leap year? How do I check for that? Don't need to care about that. That's taken care of. Down here, this returns the number of leap years between year 1 and year 2 inclusive. So the precondition is that 0 is less than or equal to year 1, which is less than or equal to year 2. Now notice, this is what you're going to implement in A. So it's going to be very useful to check if something's a leap year. Continuing on with the outline, you've got first day of year. Okay, so it's going to return 1. 0 denotes Sunday, 1 is Monday, 6 denotes Saturday. Then returns N, where month, day, and year specify the nth day of the year. 1 for January 1. That's month 1, day 1 of any year. Precondition, the date represented by month, day, year is a valid date. Again, you don't care how it's done, just that it's going to do it. And notice down here, this is day of week. Returns the value representing the day of the week for the given date, month, day, year, where 0 denotes Sunday, 1 denotes Monday, and so on. The precondition, the date represented by month, day, year, is a valid date. It tells you there may be instance variables, constructors, and other methods, but they're not going to give them to you. Now, for the very first one, we needed to count the number of leap years. Well, remember that you get the first year and the last year. So first, initialize the count to 0 outside the loop. Then start Y is the first year, and as long as Y is less than or equal to the second year that was input, you're going to go through the loop. Each time you go through the loop, you increment it by 1. Then use this function, if is leap year Y. If it's a leap year, I'm going to count it. If it's not, I don't count it. And it just loops around. Notice if none of the years are a leap year, my return will be 0. Otherwise, it will count however many years I have. Here's your scoring rubric. Okay, notice it actually tells you to call leap year. Now, you don't get the scoring rubric, but it's checking. You call is leap year. Okay? You're not going to get this point if you don't do it in a loop. Okay, so you have to have some kind of a loop. Updates count based on result of calling is leap year. If you do not, your response earns the point even if you do not use a loop. So let's say you only came in and you just checked year 1. You checked leap year and you incremented it. You would get those points. You wouldn't get this point for looping through it. Okay, updates count based on result. If you didn't initialize the counter and you didn't use a loop, you would still get this as long as you have this right here. So these 2 points come from this code. Return count of leap years plus 1. Okay, this has got to be done. If you didn't use a loop, you don't get this point. If you don't update and initialize the counter, you don't get that point. If you return to early inside the loop, like right in here, you wouldn't get that point. So this point and this point have to do with the loop. This point here is right here. It says you initialized count outside. So notice 5 points, and for a fairly simple method. Okay, the next one, you need a day of the week. So you have your start day, and that's equal to the first day of the year. Int nth day equals day of year, month, day, year. So you're past the month, the day, and the year. Int return day, start day, plus nth day minus 1, mod 7, because there's 7 days in a year, or 7 days in a week. Your return day. Notice, here we go. Notice that a lot of this right here, you're using code that was already written, but you didn't have to look at the code. You just had to know what it was giving you. So you got your year past, a month, a day, and a year. The first day of the year, you want to know is the first day of the year, a Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So you get that one. Int nth day. Day of the year, you pass it the month, the day, and the year that you've got. And then you return the start day, because you got to know, where did you start? Notice, if you called first day of year, you get a point. If you called day of year, you get a point. Now, you don't get the point if you have the arguments out of order or you don't use the year that's given. So you have to make sure that you use this year and that here you've got month, day, year in the correct order, or you lose that point. Calculates the value representing the day of the week. Okay, so here, this calculation right here is worth 1 point. If it's not done correctly, you will lose that point. Returns the calculated value. Okay, return the value from calling first day of year or day of year. So you return this guy. Notice that you return a constant value. You realize that if you do this, this, and this, you can get 3 points. Even if you mess up this calculation, you would get 75% of the points. That's not bad. So don't get overwhelmed trying to make sure everything's 100% perfect. It might not be. You're going to be under a time crunch. There's going to be a certain amount of pressure and anxiety, and that's okay. Take a deep breath, think about what you're doing, and just do the best you can. Now, from 2021, at the time I made this presentation, the scoring rubric had not yet been released. So we're just going to go over it and give an example of what it would look like. For this question, it involves the word match class, which stores a secret string and provides methods that compare other strings to the secret string. You will write 2 methods in the word match class. Okay? So now, oops, and you know what? I don't know why I did this, because this was not actually part of it. Boop. Okay? Again, sometimes you're going to be given things or given method headers without any of the implementation details, and that's okay. You just have to know you might or you might not be able to use that as you move forward. Okay? They're going to give you all of this information. Here's what you're going to implement in part A, score guess. And then down here, you're going to implement this in part B. So let's look at part A and part B. Part A, you're going to write the word match method score guess. To determine the score to be returned, score guess finds the number of times that guess, which is a string, occurs as a substring of secret, and multiplies that number by the square of the length of guess. Occurrences of guess may overlap within secret. Assume that the length of guess is less than or equal to the length of secret. So you're not going to ask, is Mississippi contained in Ohio? Ohio is too short, okay? They give you some examples. Again, remember, if you're a little confused by this, the value of guess is I, okay? The word match game, Mississippi is your secret word, okay? Mississippi is your secret word. How many times does I occur? 1, 2, 3, 4. And the length is 1. So 4 times the square of the length is 4. ISS occurs once, twice. So it occurs twice. However, the length of ISS is 3, so 3 times 3 is 9, times 2 is 18. ISSIPP, that only happens once, but it's 6 long. So notice it gets a nice big score. If I tried to check if it's Mississippi in Mississippi, it is. It's 11 characters long, and I get 121. A second one, AABB. Here are my guesses, score calculation, return. Once you understand what's going on or what a particular method is doing, you don't have to keep looking. You can scan a little bit and maybe look for something like, oh, here's what happens when one doesn't exist at all. Okay? But otherwise, once you understand what you need to do, you want to do it. But again, don't jump ahead too quickly. Now, to complete this particular method, okay, the precondition is that 0 is less than guess.length, which is less than secret length. So here, you get your guess. Your count is 0. Remember, initialize that count outside of the loop. For I is set to 0, I is less than secret.length, because you're going to go through, remember, secret is the word that you're going through, I++. If guess dot equals secret dot substring. And remember, these are strings, so you have to use the dot equals method. If you use double equals, that's not going to work. I don't know how they're going to score it, but you might get a half a point for attempting to compare, a full point for correctly using the equals. Okay, so you're going to compare it with I and then I plus guess dot length, because remember, you want to check that whole thing. And if they're equal, you're going to increment the count. Okay? You come out of that loop, and then you go to the next letter, and you continue checking. When you're all done, you've got to return your count, and then notice guess.length times guess.length is the square of the length of the guess. Again, not a terribly long or complex method. Usually the longest amount of time you're going to spend is trying to understand what you need to do. Word match, find better guess. This returns the better guess of its two string parameters, guess 1 and guess 2. If the score guess method returns different values for guess 1 and guess 2, then the guess with the higher score is returned. If the score guess method returns the same value, then the alphabetically greater guess is returned. The following example shows a declaration and shows the examples. Okay, so notice if I try 10, if I've got concatenation, if I guess 10, it's a score of 9. Nation is a score of 36. Game.find better guess, 10, and nation will return nation. So it's going to return the string, not the score. If we try con and cat, they're both going to return 9. But find better guess will return con because alphabetically it's larger, meaning it comes later. Okay? So now let's look at the code. You're past guess 1 and guess 2. Remember that you can assume, at this point, you may assume that score guess works regardless of what you did or did not write for it. So if you had no idea, you understand what score guess is going to do, but you had no idea how to write it, it's okay. For part B, assume part A works. Okay? Because part A is not going to be scored on this portion. So if score guess, guess 1 is greater than score guess, guess 2, you return the guess 1 string. Else, if score guess 1 is less than score guess 2, you're going to return guess 2. Now, if neither one of these occur, then you know that their scores were equal. So now, if guess 1 dot compare to, not equals, but compare to guess 2 is less than 0, you're going to return guess 2 because that means that guess 2 is the bigger value. Otherwise, you're going to return guess 1. And notice you're going to return guess 1 if guess 1 and guess 2 are the same or if guess 1 is larger. Okay? And again, down here, could you make this a little more complicated? Absolutely. But this is the cleanest, if you will, or a very clean option. All right? And for this, I'm not sure how they're going to score it or how they scored it, but you're probably going to get a point for returning the correct string based on the score for calling score guess. And then if the scores are equal, you're going to get a point for attempting to or trying and correctly returning the larger alphabetical one. Okay, that was some practice. Now notice that on the AP exam, you only have a limited amount of time. You're going to have 4 questions, okay? And you have an hour and 45 minutes. This is 50% of your grade. An hour and 45 minutes to do 4 problems. Here, we essentially did 4 problems. So this should not have taken more than an hour and 45 minutes to complete. Okay? Fantastic.